Morning, everyone. Sorry I am not there today. My toddler was sick last week and I have caught whatever mysterious toddler illness she has. So, for today, we are going to just go over the notes we did on Friday. So, if you were absent on Friday, a blank copy of the notes should be in the purple or blue folder when you first walk in. Everybody else, if you want to take your notes from Friday out, these are the two main important ideas that we talked about on Friday. So Friday we started chapter 2, and Friday was all about percentiles. The thing that I want to make sure that you are always aware of percentiles is that we are always at a specific percentile. You are never in a specific percentile. So percentiles are the percent of values that are less than or equal to a specific value. I think on Friday I used the phrase like at or below, like constantly at or below, at or below. So percentiles, if you are at the 50th percentile, that is equal to 50% and less. Okay? The other thing we talked about with percentiles was a cumulative relative frequency graph, or ogives, but they don't call it ogives anymore. That pretty much is when you have a set of data values on the horizontal axis, and then the vertical axis goes from 0 to 100. You can also have it in like decimal form, like 0.1, 0.2, 0.3, 0.4, and then it would just end with 1.0, which is still 100%. Remember that for a cumulative relative frequency graph, they have a bunch of different single dots, and then they connect those dots in each segment. So different slopes of lines represent different amount of data points. So the steeper the slope of the line, the more data points that fall in that interval. And then I always want to hone in the fact of connecting what we did in chapter 1 with box plots to what we're doing now. Please remember that with box plots you have quartiles. And so the first quartile is technically the 25th percentile, the median is going to be the 50th percentile, and the third quartile will be the 75th. So all of those things still work together. All right, I'm just going to let you pause and read what the answer for this is, but if you have any questions about whether or not you got this right, let me know when I get back and we can talk about it, but it should look something like this. Number 2, same thing here for counting the 80th percentile. You should know hopefully that 40 out of 50 states is where the 80th, or that's 80% of 50. And so when you count and find the 40th dot, it is in fact 13.8%. And then you can also pause to look at this one as well. The AP exam doesn't need for you to have the exact same answers as I do. You can kind of tell, like on that 30 minutes one, I kind of went a little down when I was trying to figure out the percentile. So it doesn't have to be exact with where I have it, but it should be fairly close. So for example, for the percentile where it was lasted less than 30 minutes, you wanted to make sure that it should be somewhere between 60 and 70 ideally for your percentage. And then whatever you picked for less than 30, you just make sure your 30 minutes or more matches up and adds up to 100%. So if you said about 70 are less than or equal to 30, then you would need to say 30 are more than 30. So those two percentages have to add up to 100. But the AP exam will have a little bit of wiggle room for where it's less than 30. Same thing when you're estimating the first quartile, the third quartile, in the interquartile range. As long as you're fairly close in the sense of like, they say that the 25th percentile should be somewhere between 10 and 15, and the 75th percentile should be somewhere around 30-ish, 30 to 35, not quite 35, so somewhere around 30-ish. So as long as you're close to there and then you found your own IQR, if it doesn't match mine exactly, you would still get full credit. If you have any questions about this, you can email me or just message me, or we can talk about it when I get back. All right, hopefully the sub has passed out this page here. Remember, you get 2 pieces of paper, so help the sub out with that because they're not stapled. Today we are doing lesson 2.1, day 2. So we're talking a little bit about percentiles still, but then we're moving into adding on and building on to some main core statistical ideas. So how well did you do on the chapter 1 test? Or how well did you do relative to your classmates? So when I get back, you'll get your chapter 1 test back. So here are the results of a random sample of 20 of the chapter 1 tests, along with a dot plot and the summary statistics for the test there. So mean was 80, standard deviation was 10, minimum, and then all of the quartiles there. What I would like you to do is I would like for you to pause this video and then go ahead and work on 1, 2, 3, and 4 with the people at your table. Try and figure out, especially 1 and 3, you should be able to determine their percentiles. And then 2 and 4 is where we're going to start to go with today. But I think that if you pause this and figure it out, then you can go ahead. Don't just copy down what I put, but I'm going to give a dramatic 3-second pause here so that way you can chit chat or pause the video and chit chat. And then once you have given it a good 5 minutes or so, then go ahead and press play again and see if your answers match. So pause. All right, so I'm gonna say that you have hopefully worked on this on your own. My handwriting is gonna be atrocious, so we're gonna work through this together, but just know I'm gonna do my best. If Biff scored a 65, what is Biff's percentile? So if you look at 65, there are 2 dots above 65, so Biff was one of those 2 scores. If you counted all the points, there are 3, oh baby, can I write 3 out of 20? Oh, that's horrible. So test scores that are at or below 65. So that right there would be 0.15, which is the 15th percentile. So Biff is at the 15th percentile. Make sure you understand that he is at the 15th. He is not in the 15th. You will get points off if you say in. If you look here, was Biff above or below the mean? This idea above or below, that's not a highlighter, above or below the mean, that's where we're going to build on for today for the new concept, above or below the mean. And by how many points? Those are going to start to go hand in hand to then talk about the main thing for today, which we're going to talk about with our standard deviations. Okay, so I'm going to start just by looking at whether or not Biff was above or below the mean. So if I look, and hopefully you could do this math here, if Biff scored a 65, the mean is given to you in the summary statistics, so you do not have to do any extra math. 80 minus 65 is 15, so hopefully you said something along the lines of Biff's score was 15 points below the mean. So 15 points below the mean. Now, by how many standard deviations is his score below the mean? And this is something that is going to be new for today. You do need to use the 10, but what I want you to be aware of is that this 10 that is up here, we wouldn't say that Biff is 10 standard deviations away. That's 10. That is the average distance all of the points are from the mean. So on average, all of the scores are about 10 points from the mean. Biff isn't 10 points from the mean. He's 15 points below the mean. And so that's very specific. And so Biff has his own specific standard deviation. His standard deviation, which I'm going to show you, and then I promise I'll show you the formula later. His standard deviation, if you found it, is, oops, that's a highlighter, is 1.5. Specifically, his standard deviation is negative 1.5, but we would say that his standard deviation is 1.5 or 1.5 standard deviations below the mean. So Biff's score is technically 1.5 standard deviations below the mean. And that is something that we're going to start to work on and try and comprehend throughout this week. All right. Now let's look, and if it isn't clicking today, that's okay. Hopefully by Friday it'll click. Marty scored an 8. What is Marty's percentile? Hopefully you could do the same thing we did. An 88. Did I say 8? 88. So you need to decide which of those 2 points it was when I look at that, and then you had to count which ones. But if you looked at all of the individual scores, you should hopefully know that it is technically the point that is on the right-hand side of that. And so I believe the left. And so this would be, what is it? 16 out of 20, 0.8, which is the 80th percentile. All right. Next, we have, was Marty above or below the mean, and by how many points? And then once again, by how many standard deviations? So hopefully you can look and see, based off of the fact that he got an 88, and the mean is 80, that his score was 8 points above the mean. Now, there's a formula to figure out the standard deviations. I will show you that, but technically his score, if you calculate it, is 0.8 standard deviations above the mean. And we are going to focus a lot on this idea of being below the mean versus being above the mean throughout pretty much all of statistics. How did I get those standard deviations of 1.5 and 0.8? Well, essentially what I was finding is something that's called a z-score. In statistics, a z-score is also known as a standardized score or a standardized test statistic. Standardized test statistic. Okay, I spelled that wrong, but you know what I'm trying to spell, okay? And a z-score is technically defined as the number of standard deviations a specific data point is above or below the mean. Now, you do get the formula for calculating a z-score on the AP exam. It does not look like what I'm about to write, though. It is definitely in more statistical terms, but since we're just dipping our toes in, I'm going to write it like this. So technically, the formula for the z-score is the value minus the mean divided by the standard deviation from the problem. So to find Biff's standard deviation, I did his test score. His value was 65 minus the mean of 80 and then divided by the standard deviation of 10. And that is how I found Biff's z-score or Biff's standard deviations. Now, his was technically negative 1.5 when you do that math, and the negative is what tells me that his standard deviation is below the mean. Same thing with what I did for Marty. I took Marty's test score of 88, and I subtracted it from the mean of 80, divided by 10, and that's how I got 0.8. So this formula here, value minus mean divided by standard deviation, is going to be very important. So let's look at Goldie. Goldie scored a 98 on the Chapter 1 test. I want to do two things. I want to find and interpret the z-score. So I'm going to use that formula, and then I'm going to interpret what that means. So I'm going to label it as z when we're finding the z-score. 98 minus 80 divided by 10. Since Goldie's score was larger than the mean, she should have a positive z-score, which she does, of 1.8. And so our interpretation there would be Goldie's, wow, test score. Oh, the writing will be nicer when I do it on OneNote, so I apologize. Was 1.8 standard deviations above the mean. So that would be the finding, and that would be the interpreting. And for anybody who likes fun movie trivia, Biff, Marty, and Goldie are all from a very, 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 hopefully you've seen it, notorious movie. And so if you know what movie I'm talking about, hopefully you know what job Goldie was aspiring for. Hopefully you at least know the movie if you don't know. But we'll talk when I come back and see if anybody can get that. All right. There are technically two mathematical operations when you are calculating a z-score. First, we take each score and we subtract the mean. Subtract the mean. And so what I would like for you to do is I would like for you to fill out this table, and once again go ahead and you can pause this. The dot plot for score that's on the left hand side here, this is the original dot plot that's on the front. What I would like for you to do is make a new dot plot on the right here where you take everybody's score and you subtract the mean from it. So you would do 61 minus 80, always making sure you do the value first and then the score second. So this would be negative 19. And then you do 65 minus 80 and so on and so forth all the way across. All right, so I'm going to give you time to go ahead and pause and do that and create the dot plots. And I'm going to use some technology magic and just have it already appear. So this is my warning to you that it's just going to appear in 3, 2, 1. Magic. So if you need to go ahead and copy these down, pause this video so that way you can copy it down, okay? What I want to look at is I want to look at what happens to three things, and this is kind of like with our socks. I want to see what happens to the shape. Oh, I do not like the color red when I'm highlighting. No! Go back. Go back! Why won't it let me go back? Okay, well, I don't know if I'm going to be able to figure out how to go back to the previous slide. So, hopefully you can pause that, but essentially the shape of the two dot plots stayed the same. The center of the dot plot, when you subtract, decreased by 80, and technically the variability stayed the same as well. So what I would like for you on that other slide before I switched it, I want to make sure you know that the shape stayed the same, the center decreased by 80, and the variability stayed the same. That's going to be something that we're going to want to internalize for statistics. So then, after we subtract the score minus mean, the second operation we're going to do is we're going to divide by the standard deviation. Divide. So I have a new table for you here with all of the subtractions, and then I would want you to divide everything by 10, and that's going to give us all of the values that we need. And then I want you to create a new dot plot with the score minus mean divided by standard deviation. So I'm going to use Movie Magic to switch it here. If you want to pause so that way you can see it, that's great. But 3, 2, 1. Magic. All right, now if I don't mess this up, now I want to compare the shape, center, and variability for this dot plot once again to the other dot plots. So if I'm looking at the shape, center, and variability, the shape of this dot plot compared to the shape of the other two dot plots is exactly the same. The shape stays the same no matter If you are adding data values, subtracting data values, dividing data values, multiplying, as long as you're doing the same operation to every single solitary data value, then your shape is going to stay the same. The center is going to change again. The center is going to change by whatever you are dividing or multiplying by. This one's a little bit weird to see that though, because our center was 0, and whenever you do 0 divided by a number, it's just going to be 0. So that's a little bit hard to see in this problem here, but essentially that's what we did. And then the variability is also going to change. And it would either change by multiplying or, whoa, that's an O, or dividing depending on the problem. So for this problem here, it technically has gotten smaller. So by that division, by that dividing of 10, it's pretty close to what we had. So yeah. So to summarize, because my other slide messed up, when you are adding or subtracting the same data value or the same value from every single data value, so we were subtracting 80 from every single value, when you do that, I want you to know that the shape is going to stay the same and the variability are going to stay the same. Shape and variability. And remember, variability is going to be like the range. That's what I'm talking about here, variability, or like the interquartile range if I really wanted to find that. But shape and variability are going to stay the same. The center is the only thing that's going to change, and the center is either going to increase or decrease depending on if you're adding or subtracting. So the center increases if you are adding and would decrease if you are subtracting. Okay, so if you're multiplying or dividing by the same number, that's going to be different than when you're adding or subtracting. So adding and subtracting, shape and variability stay the same. Center increases if you're adding, it'll decrease if you're subtracting. Okay. If you are multiplying or dividing by the same value every single time, what I want you to start to memorize is that once again, the shape of the distribution will stay the same. Whoa. Then what I want you to be aware of is that both the center and the variability are going to change. Center and variability change. And it's either going to change by multiplication or it's going to change by division depending on what operation you're using. Okay, so no matter what, the shape stays the same. The center only changes, or the center will change both times, but the variability only changes when you're multiplying or dividing. So we want to make sure we're good with that. Okay. Last thing I'm going to leave with you, but I'm not going to go too far into it because we'll talk about it more when I get back, is what is the mean and standard deviation that we just found. So if you look at that last dot plot at the very end, what I want you to be aware of is that the mean of that dot plot is 0 and the standard deviation of that dot plot is 1. A mean of 0 and a standard deviation of 1 is going to be essential for pretty much all that we are going to be doing in stats, but I want you to be aware of that is only for the distribution of z-scores. That is just for our distribution of our standardized test scores. Okay. All right, that should be it. We will fill this big ideas out tomorrow, so I'll make sure I have it all filled out for you to look at. You now have the on the check your understanding problems. There are 3 problems there, so please make sure that you do that. And then tomorrow we'll go over everything, do a little bit of review, and then since I've been sick or since I'm gone, I'll probably do another practice quiz this week instead of it being an actual quiz. But we will need to do a quiz this week, but since I'm sick and missing today, I guess a gift to you will that'll be another practice quiz like the first one. All right. Email me if you have any questions, issues, or concerns, and I will see you soon. Bye.